In this video, we're going to graph quadratic functions. The graphs of quadratic functions are called parabolas. Here are some key features that we will work through when graphing quadratic functions. The first is the vertex. The vertex is either the highest or lowest point of the parabola, and it's where the parabola switches from increasing to decreasing and vice versa. Next, we have the x-intercepts. The x-intercepts are where the parabola crosses the x-axis. This one has 2, but a parabola may have 1 or even no x-intercepts. Next, we have the y-intercept. The y-intercept is where the parabola crosses the y-axis. Every parabola always has 1. Finally, we have the line of symmetry. The line of symmetry is the blue line, and it cuts the parabola exactly in half. Knowing these key features helps us graph quadratic functions. We can graph the quadratic function either by factoring or by completing the square. We're going to do one of each. First, we're going to talk about graphing by factoring. When you graph by factoring, you want it to be in factored form. We learned this in a previous lesson. In factored form, x squared plus 2x minus 3 is the same as x minus 1 times x plus 3. The first step in graphing this quadratic function in factored form is to find the x-intercepts. To do that, we want to find the roots, or we want to set each of these to 0 and solve. Let's solve the one on the left first. We need to add 1 to both sides, and we find that x is equal to 1. On the one on the right, we need to subtract 3 from both sides, and we see that x equals negative 3. These two roots are our x-intercepts. We can go ahead and plot these on the graph. Next is to find the line of symmetry and the vertex. To find the line of symmetry, we want to take the average of the x-intercepts. So 1 plus negative 3 divided by 2. That's the same as negative 2 divided by 2, which is negative 1. So we know the line of symmetry is at negative 1, meaning that the x value of the vertex is also going to be negative 1. We need to find the y value of the vertex. We can come back up to our factors and plug in a negative 1 for x. Negative 1 minus 1 is negative 2, and negative 1 plus 3 is 2. Negative 2 times 2 is negative 4. So our vertex is negative 1, negative 4. You can plot that on your graph. Our final step is to find the y-intercept. Our x is 0 when we have a y-intercept. So what that means is that we can plug 0 in for x and solve. 0 times 0 is 0, so those cancel. 2 times 0 is 0, so those cancel, and we're left with negative 3. So our y-intercept is negative 3. Now we can connect our points, and we have our parabola. Now we can graph by completing the square. The first step is to move this plus 8 by subtracting 8 on both sides. We have x squared plus 6x, leave a space, and it's going to equal negative 8. Now we're going to take half of 6, which is 3. We're going to square it and add that to both sides. That's completing our square. Next, we're going to bring down this first variable, the first operation, this 3, and we're going to square it, and then we're going to solve the other side. 3 squared is 9, and 9 plus negative 8 is 1. Next, we need to get rid of the square by square rooting. What you do to one side, you have to do to the other. That leaves us with x plus 3 equals plus or minus 1. We now can set it up so that we have x plus 3 equals 1 and x plus 3 equals negative 1. When we solve these, this is going to get us the x-intercepts. So we can solve the one on the left by subtracting 3, getting us x equals negative 2. And we can solve the one on the right by subtracting 3, and we get x equals negative 4. These are our x-intercepts. So we can plot those on our graph. The next step is to find our vertex. I'm going to rewrite this to have what we had before we square rooted. Our vertex is going to be the opposite of this term, that's negative 3, and the opposite of this term, that's negative 1. So our vertex is negative 3, negative 1. We can connect our points and we have our parabola. The two equations that we solved together had two x-intercepts. You can have two x-intercepts, one x-intercept, or none. The discriminant can help us determine the amount of x-intercepts. This is the discriminant, b squared minus 4ac. If b squared minus 4ac is less than 0, meaning it's negative, then there are no real roots, and there's no x-intercept. If b squared minus 4ac equals 0, then you have one real root, meaning that parabola touches the x-axis. And then if b squared minus 4ac is greater than 0, there are two real roots. That's like the two examples we did together.